Hi guys, today we'll solve problem on differentiation, calculus 1, differentiation from first principle. Now the question is, find from the first principle the derivatives with respect to x of y equals 3x squared. Now solution, y is equal to 3x squared. Now, we call this equation 1. Now, let there be a little change in y and change in x also. So, if you add the change in y here, y plus change in y equal to, now anywhere you see x on the right hand side, you add change in x to it. Okay, anywhere you see x, it becomes x plus change in x. So we have 3x plus change in x all squared. Okay, so replace x with x plus change in x. Now we have to expand this. Now expanding, this is the same thing as 3x plus change in x times x plus change in x. Remember, squared, we are trying to expand the bracket. So expanding, we have x times x. Okay, so that will give us 3. Okay, so we are using this to multiply this, to expand these two brackets. So we use x to multiply x plus change in x. Then use plus change in x to multiply the second bracket, x plus change in x. Okay, expanding, we have, now I'm teaching this for those that don't do further maths, that might not know binomial expansion, but we can use binomial expansion to fit the answer straight. But for the sake of those that don't know binomial expansion, this is how to expand it. X times x will give us x squared. X times change in x will give us plus x delta x plus delta x times s will give us x delta x. Delta x times delta x will give us delta x squared. Okay, so now if we collect like terms, this and this are the same, so that will give us 3 brackets. Okay, so we have x squared plus 2x, x delta x plus x delta x will give us 2x delta x plus delta x all squared. Okay, so multiplying by 3, opening the bracket, we have 3x squared. 3 times 2x delta x will give us 6x delta x. And 3 times delta x squared will give us 3 delta x squared. So we have 3 delta x squared. Okay, so at this point, we subtract, we call this equation 2. Now, subtract equation 1 from equation 2. These are equation 1 from equation 2. So subtracting, so we subtract y from the left hand side and subtract 3x squared from the right hand side. So we have y plus delta y minus y equal to 3x squared plus 6x delta x plus 3 delta x squared minus 3x squared. Okay, so subtracting equation 1 from 2, meaning you subtract y from the left hand side, y plus delta y minus y. Okay, then subtract 3x squared from the right hand side, which we've done. Okay, so now this minus this will give us 0. 3x squared minus 3x squared goes. Now y minus y goes. So we have that delta y is equal to 6x plus, sorry, so we have 6x delta x plus 3 delta x squared. Okay, so at this point, divide both sides by delta x. So we divide through by delta x, divide both sides by delta x. So if you divide both sides by delta x, I'm cleaning this. You're going to have delta y all over delta x equals 6x delta x all over delta x plus 3 delta x squared all over delta x. So delta x here will cancel delta x, and delta x here will cancel one of the delta x. Remember, it's squared, so meaning 2 of it. Okay, so if that happens, we are left with delta y over delta x equals 6x plus 3 delta x. Now we take the limit as delta x tends to 0. Okay, so we say dy dx is equal to limit of delta y over delta x as delta x tends to 0. So taking the limit as delta x tends to 0 will give us 6x plus 3 times 0. Okay, so delta x tends to 0, meaning anywhere you see delta x here, you put 0. Okay, so that's going to give us 3 times 0 is 0, so we are left with 6x. So therefore, dy dx is equal to 6x. So differentiating 3x squared, y equal to 3x squared with respect to x